So factoring a perfect square, quadratic, or trinomial is three terms, right? So it could be called a trinomial. Now, this is our normal standard form, and we know we got to get into a factored form. A perfect square trinomial happens to follow this pattern. This pattern looks confusing. What it's saying is the square root of the first term and the square root of the last term. Okay, so first of all, they are perfect squares. We can square root them, multiply the two values together, and then multiply that by 2, and that will give us our middle term. If that's the case, we can simplify the factoring to the square root of the first, and the square root of the last, so c, in one bracket squared. Very confusing when I just say it with general terms and letters. So what we're going to do is here's the standard form. It looks no different from any other quadratic that's a trinomial we'd be factoring. Okay? And what I want you guys to recognize here is we're going to factor it the way we would normally factor. Just at the end, I want you guys to recognize that this is a perfect square quadratic. So, if I'm going to work on this one here, factors of the first term. There are a lot of factors to this. Okay? We have 1 in 64, 2 and what? Good. Does 3 go in? No. Does 4 go in? Yeah, how many times? Does 5 go in? 6? 7? No. 8? 8 times what? Okay. So once we've gotten to 8 times 8, we know we've got all of our factors here, right? And 25, what do we got? 1 and 25 and 5 and 5. Okay. So, in this case, I have a lot of options for the first terms inside of our brackets, and we only have 2 options for the second. Now remember that our product here needs to add to what value? Negative 80x. And remember, all of these technically have an x. Okay? So we know our final answer, our f at x, is going to be in the form of like this. Our first term is going to come from one of these 4 brackets. We have to figure out which one. And our second terms will come from one of these 2 brackets. Okay? So I'm going to go real quickly through this. Obviously, 64 times 25 and 1 times 1 will not give us this. Okay? So I'm going to jump across. 64 and 1, 1 and 25. 64, 25, will that give us 80? No. Okay? And then quickly, 1 times 5 and 5 times 64, is that going to work? No, we're going to have 300 and something. It's not going to work. So we know this first column is no good for what we're doing. Okay? Second column. 32, 25, number's going to be way too high. So let's just try to go across. 32 times 1 and 2 times 25, that's 32 and 50. Is that going to work? No, it was close, but didn't happen. 32 times 5 is going to give us 150 something. Obviously going to be too high. Okay, so we know that this one's not going to work. Okay, and somebody's already figured it out. What are they?
8 times 5.
Okay, so someone's already figured out that 8 times 5 and 8 times 5 will give us 40s. Okay.
Negative 5.
And now they both have to add up to negative 80. How would both of these add to negative 80? What do they need to be? They both need to be negative, which means these terms need to be what? Both need to be negative. Does negative 5 times negative 5 still equal positive 25? Great. So we have our values. Now I have 8x and 8x in the first one. And remember, we got to put them in the opposite brackets. Well, is that going to make a difference here? Why not? Because it's the same number, so it doesn't matter if I put it in a different bracket or not. The brackets will be what? The same or identical. So because they're identical, what we can do is we can represent this with just one bracket. I could write it as 8x minus 5 squared. And a perfect square trinomial will have 2 brackets that are identical. So how does this answer relate to what we had done up here? Well, if we take a look, a squared. In other words, what's the square root of 64? 8, that's right. So I could have written 8 here. And sorry, because it's x squared, what's the square root of 64x squared? 8x. Okay. And what is the square root of our 25? 5. This represents the middle terms operation. What was the operation in front of the 80? Negative. If I had recognized it was a perfect square trinomial, okay, if I had recognized it was a perfect square trinomial, I could have took the shortcut and square rooted the first and last term and just took the middle value, and that would have been the factored form. But there's a lot of mental math involved, so if you're not capable of doing that, you can just factor it the way we normally do. And if you can, excellent. It's a very fast way to solve that style. Okay?